What you are looking at is a trap. That glowing accretion disk is swirling around a void, so incredibly dense that to escape it, you would need to move faster than the speed of light. Once you cross that boundary, you are falling in a way that light itself forgets how to climb. There is no sound, no wind, only an ancient, indifferent pull. This glowing, distorted ring of matter outlines the physical boundary of a dead star. When a star far more massive than our Sun burns out, its core collapses under its own immense gravity. The resulting wound in space-time creates what physicists call the event horizon. It is a literal point of no return. If I were watching you fall toward that boundary from a safe distance, I would never actually see you cross it. From my perspective on the outside, you would appear to slow down, dim and freeze at the very edge. Your image would smear into the distorted starlight, leaving you trapped there forever as a cosmic ghost. The rest of the universe writes you off as a fading photograph, but for you inside the fall, there is no freezing. You accelerate inward, moving faster and faster toward a complete dismantling of your physical form. Take a look at this vertical vector diagram. If you fall toward the center feet first, your feet are physically closer to the massive mass than your head is. That slight distance means the downward gravitational pull acting on your feet becomes dramatically stronger than the downward pull on your head. Physicists have a highly specific term for what happens next. Spaghettification. You are pulled apart by invisible, relentless hands stretched lengthwise and compressed sideways, atom by atom into a thin glowing filaments of matter. Your skin and bones do not snap first. The weakest bonds in your biology surrender early. The water inside your cells, the soft tissue between your vertebrae and collagen holding your knees together, simply give way. That brutal stretching happens before you even cross the event horizon of a small black hole. But if the black hole is supermassive, millions of times the mass of our Sun, its immense scale creates a much gentler gravity gradient at the edge. In that scenario, you could cross the horizon completely intact, whole, still thinking. Yet regardless of the black hole's size, the destination is identical. Eventually, extreme gravity will tear your flesh apart. Your biology cannot survive the descent, leaving only your consciousness and the raw atoms of your body hurtling inward as you fall deeper. Gravity begins to distort time inside your own frame of reference. Your watch ticks normally, your heartbeat holds steady, but relative to the outside universe, your personal clock is crawling. A single second for you takes years for everyone you left behind. Looking backward through this tunnel, you see relativity in action. The light pouring in from the outside universe catches up to you. It gets heavily blue-shifted and intensified. Entire civilizations rise and fall, stars burn out, and the whole future history of the cosmos compresses into a single, blinding flash of light directly behind you. Look forward and you see the opposite. Light from the matter that fell in long before you arrived is heavily redshifted. Those ancient remnants stretch into dim, fading infrared ghosts sinking into the dark. Extreme gravity has now completely severed your timeline from the rest of reality. You are locked in a private one-way pocket of spacetime, watching the universe die in your rearview mirror while racing toward your own end. This grid models the exact center of the black hole. Spacetime curves infinitely downward into a single, sharply defined point that is the singularity. It is a location of infinite density, where the known laws of physics simply stop. Two fundamental rules clash at this exact spot. General relativity dictates that space-time curves infinitely, crushing everything. Quantum mechanics insists that information can never be destroyed. Both statements cannot be true at the same time. This contradiction creates a mathematical dead end. It is the absolute frontier of human knowledge. When physicists try to calculate what happens here, the equations literally break down into chaos. Without working math, we only have theories. The singularity might crush you into a microscopic point, scrambling your atomic data beyond any recognition. Or, as some models suggest, it could be a gateway, a bridge leading to another region of spacetime altogether. We do know this by the time you reach the center. You are no longer experiencing time, and you are no longer matter. Human existence ends. You are reduced to a microscopic mathematical pattern, pressed tightly into the deepest fold of the universe. The mathematics on this chalkboard describe a discovery made by Stephen Hawking in 1974. Black holes are not entirely black. Because of quantum effects at the event horizon, they emit a faint thermal energy. We now call it Hawking radiation. This energy leak is incredibly slow, but over time scales that make the current age of the universe look like a passing second. This continuous radiation causes the black hole to shrink, fade, and eventually evaporate into nothing. This raises a devastating question for physicists. If your physical body was destroyed, and the black hole itself eventually vanishes, where did you go? What happened to the fundamental quantum information that made up your atoms? Watch this dissolving sphere. Modern theoretical physics suggests your information is not permanently lost. Instead, it gets intensely scrambled and then leaks out through that slow, faint mist of thermal radiation drifting into the void. This agonizingly slow evaporation means the core essence of your data is radiated outward, atom by atom, memory by memory. You are whispered back into the surrounding cosmos across trillions of years. The gravity gradient dismantled your physical body. The event horizon stole your time, but the universe preserves your fundamental information as a scattered quantum echo. In the strangest possible sense, you never truly die.